Hi guys, N0ECK here. Part of most every digital interface box is a switch for the push-to-talk button on the radio. Some radios can do this via CAT control, some hams just use Vox. In my situation, the ICOM 718 doesn't do push-to-talk via CAT, and the radio can hear its own output via my audio mixer, so Vox is pretty much out of the question. I was pretty sick of holding down the foot switch during digital QSOs, so I needed to go old school and build a serial interface for push-to-talk. The basic premise of the project is to take a serial line and use that to turn on an opto-isolator that will pull a pin to ground. That's all the push-to-talk switch is, a small voltage from the radio that is shorted to ground and the radio switches into transmit. As an added feature, the Morse key line is basically the same thing. My computer, like most modern systems, doesn't have an actual serial port. All of the software I wanted to use has provisions for serial keying and not much else. So I was forced to use a USB to serial adapter. I chose the FTDI-based RS-232 breakout board from SparkFun, not a sponsor, because it has plated through holes that provide easy access to the power outputs. The software gives me two options, RTS and DTR. These lines are supposed to go high when the push-to-talk is activated. So I pushed an LED with a current limiting resistor into the RTS hole and the hole marked ground, or GND, on the board. This provided me with a nice steady green light that went out when I keyed the push-to-talk in FLDigi. I was okay with this, figuring I would just have to check a box for reverse or something. There's a box in FLDigi for RTS plus V, and that did exactly what I wanted it to do. I temporarily soldered on one of the opto-isolators and connected its output in parallel to my foot switch. That's wired to the 718's push-to-talk line. Everything seemed to work the way it was supposed to until I tested it with Digital Master 780, part of the Ham Radio Deluxe suite that I like to use for rag chew contacts, not contesting. The RTS plus V option didn't exist in that program. Also didn't exist in N1MM, which is very important to me. So I started thinking that maybe something was backwards. I desoldered the opto, got out my LED and flipped it around and put it in other ports. I tried a lot of stuff with no results. Sometimes you need a break. Something to take your mind off your troubles. That's when a cool, refreshing beverage will put you in the right headspace. Version 2.5 Wet Hopped Pale Ale uses the freshest hops grown locally. We use those hops with the finest tap water and locally sourced grain to make the best beverage for break time. Version 2.5 from Open Source Brewing. Update your brain's operating system. Sometimes you have to take a break and come back later. So the next night, I came back and started measuring things with my trusty multimeter. There was 5 volts between RTS and ground, DTR and ground, TX0 and ground, RX1 and ground, the list goes on. I started to think, what if ground isn't ground, man? And I tried something different. I probed between RTS and DTR, TX0 and RX1, and a few others, all while changing states within the software. I hit upon something interesting. There was no potential between RTS and TX0 when push-to-talk was inactive. There was also no potential between DTR and TX0 when push-to-talk was inactive. When push-to-talk was active, there was minus 5 volts between each of those signal lines and TX0. I had just found my ground. Sorta. So the whole thing was a little backwards because the LED in the opto-isolator is a diode and requires me to think in conventional current flow instead of electron current flow. That just means I had to think like the TX0 line was the current source and the DTR and RTS lines were just pushing back with equal force when the push-to-talk wasn't active, or you can kind of act like they're ground. I'm not super good at electronics, I just kind of fiddle. I had used the demo schematic for the opto-isolator in my testing, but I found that the 5 volt and associated current supplied by the USB to serial adapter was well within spec for the input of the opto. The output side was a very minimal current being pulled to ground. Resistors might actually hamper that operation. So I went ahead and tried it without any of those parts. When it worked as expected, I started building. If it fails a year or so from now because those parts are missing, I guess I'll have to repair it. I was going to drill off some of the copper to make islands for the opto pins, but I couldn't find the hole saw bit I purchased specifically for that job. So I made some of the ugliest Manhattan pads you could ever make. If you score PCB with a utility knife and secure it in a vise, it will break on that line with a nice ragged edge. I made 4 for each opto isolator, 1 for each leg, glued those to a PCB with some super glue. While the CA was drying, I decided to use RCA jacks for the output so I could move the box to other computers and other radios by just building a cable instead of rewiring the whole thing. I soldered a piece of shielded audio cable with an RCA end in parallel with my foot switch and made up a RCA to 3.5mm plug for the key line on the CW key. I went ahead and used a stereo plug and put the signal on the tip because the ICOM 718 does not like mono plugs in its CW key jack. When the glue was dry, I soldered down the opto isolators, ran the wires to the serial adapter, and tested the assembled product with a voltmeter. Everything was working as expected. When I plugged it into the push-to-talk line parallel with the foot switch, it didn't work.
You get nothing! You lose! Good day, sir!
Yep, just my luck. After thinking for a second, I realized that I had just guessed which wire was signal and which one was ground on that push-to-talk interface. I flipped those 2 lines and everything was happy. I even plugged in my DTR line to that CW key jack and it works like a champ. During setup, I made a nice short QSO on 40-meter PSK. Since then, I've tested it with DM780, FL Digi, N1MM. They all work as expected. I even used it with N1MM in a couple of CW contests, and so far it's working great. Now, every rig is different, and every computer is different, but if you take a second to think differently, you might find your solution. Remember, the amateur radio license is really just a lifelong learner's permit. Don't hesitate to leave your comments down below or on Facebook or Twitter. Remember, if you share our video, you're helping other hams get into the hobby or expand their knowledge, or maybe just prove me wrong. I actually enjoy being proven wrong, so if I'm completely off, especially about those optos that are going to fail in a couple months, please let me know in the comments or on Facebook or Twitter. 7-3, join the resistance.